Hello, this is Adel Cola, and this is my Stat 215 honors project. My question was, does gender affect the probability of you knowing more than one language? Here was the data collection process. So data was randomly collected from the Census at Schools Random Sampler. A sample size of 239 12th graders from the state of Michigan was taken. There were 114 males and 125 females in the sample. From this, we took the proportion of students who knew more than one language and compared the genders. A large sample size was taken in order to have a more accurate estimation of the population. A limitation could possibly be that the sample size is not large enough. Of course, the bigger the sample size, the more accurate the estimation of the population is. The sample data was a bit too big to show here, so I haven't included it in any of the slideshows. However, you can see it all over here. Okay. Here we see a bar chart of the languages known for males and females. So there were 239 total students, 169 knew only one language, and 70 knew more than one language. So approximately 29% of them knew more than one language. Here is a bar chart for the males. So 114 total male students were there. 79 knew only one language and 35 knew more than one language, so approximately 31% knew more than one. And here's the bar chart for females. 125 total females were in the sample. 90 knew one language and 35 knew more than one language. And 28%, so about 28% knew more than one language. So we want to determine if this difference is statistically significant. So we can see that the proportion of males who know more than one language, which is 0.31, is different from the proportion of females who know more than one language, which is 0.28. We can also see that both proportions are different from the overall proportion of students who know more than one language, which is 0.29. So in the next slides, we will examine if these differences are statistically significant. Here we have a one proportion z-test for males. First, we want to verify our assumptions. So this is a randomly collected sample. It is independent. A large population was taken, and both of the proportions of successes of knowing more than one language and the failure of such are more than 0.10. Our null hypothesis is the proportion of males who know more than one language is equal to 0.29, and the alternative is that the proportion is not equal to 0.29. When we put in these data values into our calculator, the result is that the test statistic, is 0.4 and the p-value is 0.6888. So the p-value is basically just the probability of an event occurring by chance, assuming that the null is in fact true. And so here is our decision at a 5% significance level. Since the p-value is not less than or equal to 0.05, we do not reject the null and in turn do not favor the alternative. Evidence favors that because the p-value equals 0.69, that the proportion of males who know more than one language is not different from 0.29. And here we have the one proportion z-test for females. The assumptions are all the same, they're all verified. And here we have a null hypothesis of the proportion of females who know more than one language is equal to 0.29, and the alternative is that the proportion is not equal to 0.29. When we put the data into our calculator, the z, which is basically just the test statistic, is negative 0.25. The p-value is 0.8054. So the decision at a 5% significance level is that since the p-value is not less than or equal to 0.05, we do not reject the null and in turn do not favor the hypothesis. Evidence favors, because the p-value is equal to zero point 0.8, that the proportion of females who know more than one language is not different from 0.29. And here we have our two proportion z-test. So the sample is random and independent. All of the other conditions were shown to be met in the one proportion z-tests. And over here, our null hypothesis is that the proportion of males who know more than one language is equal to the proportion of females who know more than one language. And the alternative is that the proportion of males is not equal to the proportion of females. We put it into our calculator, and the test statistic comes out to be 0.646, and the p-value is 0.6467. So our decision at a 5% significance level would be that based on the evidence, we would not reject the null hypothesis and in turn not favor the alternative. Evidence shows the p-value equaling 0.65, that the proportions of male and females who know more than one language does not have a difference. And here we do a chi-square test. This is our setup. The assumptions need to be verified first. Everything stated in the proportion tests were met, and the additional condition of all expected counts being greater than or equal to 5 is also met. The null is that gender is independent when dealing with more than one language, and the alternative is that gender is dependent when dealing with knowing more than one language. Our alpha level is 0.05. This is our chi-square test. First, so we put all of our data into a table. This is our table of observed data values. Now we put this into a matrix in our calculator, then we put this matrix into a x-squared two-way test as the observed matrix. This x-squared two-way test is basically just a test you do on your calculator to determine a chi-square test of independence. So the x-squared value comes out to be 0.2101. The p-value comes out to be 0.6467, the same as the p-value in the two proportion z-test. So our decision based on the evidence would be that we would not reject the null and not favor the alternative. Evidence shows the p-value equaling 0.65 that the proportions of male and females who know more than one language does not have a difference, statistical difference. And here is our conclusion. So our original question was to determine if knowing more than one language was related to gender. Through all of our tests that we've done, we can conclude that based on the sample that we have, that knowing more than one language and gender are unrelated. We can firmly say that. It is not more likely to know So you're not more likely to know more than one language if you are a male or a female. So for both of our one proportion z-tests, we see that the individual proportions of each gender were not statistically different from the overall proportion for both genders. For our two proportion z-test, we could see that the male and female proportions of knowing more than one language showed no difference. And finally, for our chi-square test for independence, we showed that there was no relatedness between male and female proportions of knowing more than one language. And our p-value in each of these tests was not borderline in any of them, which means that we can firmly say that these two are not related, because borderline means that a p-value needs to be between 0.01 and 0.10, and it's way above that. So we can be confident that they are not related, but there is, of course, a chance that they are related. But yeah, thank you for watching and listening. I hope you liked it. I really did work hard on this, so and it was the first time I've done something like this. So thank you and have a nice day.